Hello, soon-to-be graduates. I am Doug Clark, Dean of the College of Chemistry, and it is my great pleasure to welcome all of you, your parents, relatives, and friends to the 2022 College of Chemistry Commencement Ceremony. This is a very exciting day. It's a momentous day, one that we haven't had the opportunity to celebrate in person since 2019. And this day belongs to you, the College of Chemistry class of 2022. One more round of applause for all of you. We have a great program in store for you this afternoon, so please be seated and let's get started. To all of our graduates, the College of Chemistry from which you are graduating has a great and illustrious history. And this year, we are commemorating its 150th anniversary. That makes you the College of Chemistry sesquicentennial class. Kind of has a nice ring to it, doesn't it? Because back in 1872, at the behest of UC President Daniel Gilman, the California State Legislature established the College of Chemistry. And since then, over 20,000 undergraduate degrees and over 8,000 graduate degrees have been awarded in our college, and there are over 15,000 College of Chemistry alumni living throughout the world. And we'll add a little over 300 alumni to that list today. And over the last 150 years, many of the most important discoveries in chemistry and in chemical engineering have been made right here. And many of the most influential members of the profession have passed through this college as undergraduates, graduate students, postdocs, or faculty. And indeed, many of the most important discoveries yet to be made, inside and outside of the laboratory, will be made by you. You are graduating from the finest institution of its kind in the world. And as graduates of the College of Chemistry, you are now part of this remarkable and distinguished history. And you deserve to take great pride in your accomplishments and in your membership in this college community, especially given the unprecedented challenges you have all endured throughout your time here. We salute you all. We, of course, all live in a chemical world and share that world. Our food and medicine, our energy and transportation, our local and global environment, our planet's changing climate. Indeed, nearly everything we touch or rely on in our daily lives is impacted by the activities of chemists and chemical engineers. It is both a great opportunity and a great responsibility. As graduates of the College of Chemistry, you are empowered to help lead the way in developing sustainable and equitable solutions to many of the world's most pressing problems and ensure that they are being implemented in a socially responsible manner. You are, after all, not only graduates of the College of Chemistry, but of UC Berkeley, the greatest public university in the world. Or, as we sometimes like to say around here, the greatest university in the world. The faculty of the College of Chemistry is pleased and proud to recognize all of you as you step forward and begin the next phase of your professional lives. Today, we honor 312 graduates of the 2021-22 academic year. 47 recipients of the Bachelor of Science in Chemistry, 53 recipients of the Bachelor of Science in Chemical Biology, 97 recipients of the Bachelor of Science in Chemical Engineering, 8 recipients of the Bachelor of Science in Chemistry, Master of Science in Chemistry, Bachelor of Arts in Chemistry, I'll get this right, it's been a couple years, we're rusty. 8 recipients of the Bachelor of Arts in Chemistry, 1 recipient of the Master of Science in Chemistry, 28 recipients of the Master of Science in Chemical Engineering's Product Development Program, 10 recipients of the Master of Science in Chemical Engineering's Bioprocess Engineering Program, 46 recipients of the PhD in Chemistry, and 22 recipients of the PhD in Chemical Engineering. My colleagues and I congratulate you all. So now on with the show. Since this ceremony honors the accomplishments of you, our students, it is most appropriate to first hear from your representatives, 2 student speakers. Both are graduating with undergraduate degrees in the college, one in chemistry and the other in chemical engineering. Our first student speaker is Artur. Artur will receive his Bachelor of Science in Chemistry with a focus in computational chemistry. Artur was born in Kazakhstan and moved to Western Canada around age 7. After spending some time in Edmonton, Alberta, he then relocated to Peoria, Illinois, for his teenage years. So I'd say that was quite a range of cultural experiences before even getting to Berkeley. And as vice president of his high school in Peoria, Artur actually has some experience in delivering commencement addresses. Initially motivated by his high school chemistry teacher, Artur became interested in understanding how the small building blocks of matter come together to make up the world we live in. And at Berkeley, he eventually focused his attention on the intersection between chemistry and physics. As a freshman, he started out working as an undergraduate researcher in the Bediako lab, and he has spent the last 2 years working in the Limmer lab. These are 2 of our stellar early career faculty. During his 4 years in the College of Chemistry, Artur was a peer tutor for his fellow chemistry classmates and a teaching assistant for a course in quantum mechanics. He also took part in our chemistry alumni mentorship program. Long term, Artur says he would like to become a professor, mostly because of his passion for teaching others about chemistry and the enjoyment he gets from seeing ideas click for others. If that plan falls through, though, he could see himself working at a national lab. Wherever he lands in the future, at least we know he's played in Peoria. Artur is off to Harvard in the fall for his PhD studies in the area of physical or theoretical chemistry. Perhaps he will follow in the footsteps of Richard Feynman, the notable theoretical physicist who Artur says is his favorite scientist. Outside of his chemistry studies, Artur enjoys hanging out with friends, running, playing video games, and scuba diving. Hopefully, he'll have a chance to do some combination of those things this summer. But in the meantime, please join me in welcoming Artur to the podium.
Hello, I'm Artur, and it is my pleasure to be speaking to you today. First and foremost, I would like to express my congratulations to all my peers and their families and friends gathered here to celebrate this amazing day. I'm ecstatic to celebrate the culmination of our hard work over the past years in the College of Chemistry and excited to look ahead into the future. But before we discuss the future, I would like to reminisce on the past. It seems surreal that we are here right now. We started off causing accidental fires in general chemistry and have now become scientists, engineers, and everything in between. I will forever cherish the memories which each and every one of you, whether friend, acquaintance, or classmate, from grinding out organic chemistry problem sets to getting boba after a midterm to de-stress, or watching the sunset at the Big C, I will never forget my experiences here. And what an experience it has been. It is exhilarating to be surrounded by world-class scholars at every step of their journeys. Thank you to all the professors, GSIs, and classmates that made my experience here the best 4 years of my life yet. Without your dedication, support, and passion for knowledge, I would not be standing in front of you today, likely graduating with a CS degree instead. I would also like to thank my amazing friends for being the support system that got me through college. Coming to Berkeley, I did not know what to expect. I was intimidated by the caliber of students I met here, coming from small school Illinois. However, slowly but surely, I made friendships that would last a lifetime. I'm sure that most of us had a moment, or a few, which made Berkeley feel like home. For me, it was watching the sunset off the Access roof, when I felt like I had found my people and finally belonged here. To echo my dear friend, one of the best parts of Berkeley is the people, and I will dearly miss all of you that made Berkeley home. Speaking of home, no graduation speech would be complete without mention of COVID. So many of us spent countless hours at whatever place each of us calls home during this time. For me, it was a time of self-reflection, stress, and sometimes loneliness. I guess no one among us really expected a world crisis to cut our college years short. However, I'm so proud of each and every one of us for persevering and becoming the beautiful people we are now. We will never get that time back, but I'm sure that it will cause us to treasure every passing moment more. But enough about the past. What are the chances of all of us being here at this moment? If I learned anything in statistical mechanics, it is that the rare events offer the most exciting outcomes. I'm excited to see where we will be in the next 5, 10, and 20 years. You may be sitting next to a future Nobel laureate or a Fortune 500 CEO. I guess only time will tell. But I'm certain that all of us will go on to do great things. Surviving the College of Chemistry's rigorous curriculum will make sure of that. I hope our paths cross again and we can reminisce on the past and regale each other with stories. Thank you, Berkeley. Thank you, College of Chemistry. And thank you to the class of 22. Go Bears.
And thank you, Artur. Our next student speaker is Zoe Altenberg. Zoe is graduating with a Bachelor of Science in Chemical Engineering. She's a native of the East Bay and grew up in Kensington, just north of Berkeley. Chemical engineering actually runs in her family, as her mom also has a degree in chemie. And while Zoe didn't think she would follow so closely in her mother's footsteps, she eventually made her way to chemical engineering after exploring several different majors, including visual arts, creative writing, geography, and atmospheric science, and also taking a little break from school. Last summer, Zoe worked as a product support engineer in OSIsoft, a manufacturer of application software for real-time data management that has its headquarters in San Leandro. There, she developed a deeper understanding of computer networks and data transfer and gained valuable research skills. She enjoyed it so much that she'll be starting a full-time job there at the end of July. This, of course, will be after she gets a much-needed break and well-deserved vacation in Italy and Greece this summer. Yeah. During her studies at Berkeley, Zoe spent some time as an undergraduate researcher in Jennifer Doudna's lab, investigating how CRISPR edits disease-causing genes, running experiments on neural progenitor cells and analyzing the results, and ultimately presenting her findings in a poster session and to the Doudna lab. She admits it was quite a surreal and somewhat daunting experience explaining CRISPR technology and research to Jennifer Doudna herself, but it was a highlight of her academic career so far, no doubt. Zoe has also contributed her talents to Enable Tech, a student organization on the Berkeley campus that designs and builds assistive technology for people with disabilities. Outside of her academic commitments, she loves baking, mostly chocolate chip cookies. Good choice, Zoe. Biking, rock climbing, training her Australian Shepherd, and skiing when she gets the chance. So please join me in welcoming Zoe to the podium.
We are here. It's kind of hard to believe it. It's really hard to believe that this single ceremony is the culmination of the countless hours, the sweat, the tears of the last however many years it's taken you to get here. It is a momentous day, to say the very least. 10 years ago, if someone told me that I would graduate from Cal with a degree in chemical engineering, I legitimately would have thought they were crazy, because that is when I started my very non-traditional college career. At the time, I had no idea what I wanted to do. I was at a different university taking a wide variety of classes, everything from visual art to sociology to physics. And it was that physics class that actually gave me an itch to go into science. Unfortunately, I was not encouraged to do so. Peers and advisors alike convinced me that I would not be capable at succeeding in STEM. And on top of all of this discouragement, I was suffering from exceptionally poor mental health, and I had zero confidence in myself. After several years of trying to persevere, I was done trying to prove to myself that I should do art or geography or creative writing. I just wasn't fulfilled by those things. And I started to question whether college was the right path for me. So I went home, I took some time off, and I took time to address my mental health, and my life turned around. I was ready to try to pursue a degree in STEM. I didn't know what exactly, I didn't know if I'd be any good at it, but I was going to try. So without any expectations, I enrolled in community college, and I started taking classes in chemistry and math and physics, and I got A after A after A. And when it came time to transfer, I got into UC fucking Berkeley. So not only do I love science and engineering, and not only am I fully capable of it, but I'm damn good at it. Now, I know most of you have had wildly different college experiences than me, but I know that all of you have also overcome your own struggles. In our time here, we have learned a lot. We have made lifelong friends. We've cultivated relationships with professors and mentors. We've made many amazing memories. And we're here today to celebrate all of that. But right now, I want you all to take a moment and remember all the times of defeat. Every bombed exam, horrible presentation, failed experiment, every moment that made you second guess yourself, maybe made you want to quit. Because despite all of that, you are here. We are here. So after today, after I'm done talking, go ahead and forget all the details of the bad stuff. But the next time you catch yourself second guessing yourself, remember that you graduated from one of the best universities in the world, despite all the obstacles you faced. So move forward into your next chapter with confidence, because simply being here at this ceremony is a testament to your future success. Never forget the pride that you feel right now, and never doubt yourself again. Who am I kidding? You are 100% going to doubt yourself again. But when you do, check yourself and remember just how much you are capable of. Remember today. And to quote Elle Woods from the movie Legally Blonde, "We did it!"
Thank you, Zoe. Okay, well, at this time, I'd like to turn the microphone over to this year's commencement speaker, Professor Michael Marletta. Now, you may be thinking, isn't Clayton Heathcock this year's speaker? Well, unfortunately, Clayton couldn't be here with us today. But fortunately for us, Michael agreed to give the commencement address this year with about 4 days' notice. Although I hear you've given 6 commencement addresses before, so we know we're in good hands. Needless to say, we are extremely grateful for Michael's remarkable show of support for the College of Chemistry today. So let me tell you a bit about Michael. Michael is a professor of chemistry and of molecular and cell biology here at Berkeley, and he holds the C.H. and Annie Lee Chair in Molecular Biology of Diseases. A native of Rochester, New York, he received a BA in Biology and Chemistry from the State University of New York at Fredonia and his PhD from UCSF in 1978. Following a postdoctoral fellowship at MIT with Chris Walsh, Michael was appointed as an assistant professor and then associate professor in the Department of Applied Biological Sciences at MIT. In 1987, he moved to the University of Michigan as associate professor of medicinal chemistry and associate professor of biological chemistry. Michael first moved to Berkeley in 2001 as professor of chemistry and of molecular and cell biology, and he served as department chair of chemistry from 2005 to 2010. He left Berkeley in 2011 to serve as president and CEO of Scripps Research Institute in La Jolla. Fortunately for us, he returned back home to Berkeley in 2015. A member of the National Academy of Medicine and the National Academy of Sciences, Michael's research lies at the interface of chemistry and biology with emphasis on the study of protein function and enzyme reaction mechanisms. He has made truly groundbreaking contributions to the understanding of an essential cellular control system, nitric oxide sensing. For example, Michael discovered both the key nitric oxide producing enzyme and the critical cellular target of nitrogen oxide. Discoveries that provided the basis for understanding this unique cell signaling pathway at the molecular level and the function of nitric oxide in the immune system. Michael's highly distinguished career is reflected in his numerous awards and honors, too many to name here and now. However, he received a MacArthur Fellowship, commonly known as the Genius Grant. He was selected as a Howard Hughes Medical Institute investigator, and he has received numerous national and international awards, including the Esselin Award in Chemistry in the Public Interest from the American Chemical Society. Michael has also been elected as a member or fellow of several professional societies, including the Royal Society of Chemistry, National Academy of Inventors, the American Philosophical Society, and both AAAS societies, the American Academy of Arts and Sciences and the American Association for the Advancement of Science. Now, I could go on describing Michael's many accomplishments and accolades, but in the interest of time, I think I'll stop there. So, without further ado, please join me in welcoming Professor Michael Marletta to the podium.
Thank you, Dean Clark. Let me offer my best wishes to Chairs Francis and Reimer, and my colleagues in chemistry and CPE, parents, family, and friends. It's great to see all of us back together in the same room, having not done so for 2 years. But mostly, let me offer first congratulations, but a hearty welcome to all of the bachelor's, master's, and PhD students that are soon going to hold that piece of paper. Congratulations. I think we all have to have someone in our life that keeps us in balance. For me, that's my wife, Margaret. And Doug, I wasn't going to say this, but you mentioned the MacArthur Award. Any of you that know anything about that know that there's a cash value that comes associated with that, and it's distributed over a 5-year period. And at the end of the 5 years, in fact, the very day of the end of the 5 years, my wife said to me, you know, I just want you to know, I didn't notice any difference. There's a couple of ways you could interpret that. You can imagine how I might interpret it. I have a recurring nightmare, and that nightmare is that I'm late for my flight, I can't find my bag, I can't get through security, any one of a combination of things. But thanks to Dean Clark, I can now replace that nightmare with another one, which is to get a call while you're sitting having dinner with your wife, asking you, would you give the commencement address 4 days hence? I like challenges, so here we are. All right, so you know that I'm not Clayton Heathcock. If you look at the program, you'll see that Clayton gave you a nice lofty title. curiosity, courage, I forget the other words in there. Doug didn't ask me for a title, but I have one. It's called adaptability. So I saw in the news the next day, after Dean Clark asked me if I would give the address, that Taylor Swift had agreed to give the commencement address at NYU. So I'm guessing you called her, but you were a little late, and so now you're stuck with me. Now, Doug did mention I have done this before, and I know my place. And the most important thing that I will tell myself as I look at my watch is don't talk too long. Those are basically the only rules that a commencement speaker should take to the bank. Now, one thing I can say with certainty is that all of you students, are a resilient group. In March of 2020, everything changed. You don't need me to tell you that. You needed to adapt how you learned. We faculty needed to adapt how we taught. Classrooms, teaching labs, research labs, everything was different, as you know. It was intimidating, to say the least. Not just for you, but for us. We faculty did the best we could with looking at little squares on a screen. And if Zoom taught us anything, it taught us how much we humans need the three-dimensional world that we're used to living in. So it's really good to be back in it. Anyway, we got through it. You're living, breathing proof of that. So again, my congratulations. Now, I have a breaking news report. Every news story seems to be a breaking news report. I have mine. And that is that the world you're about to step into isn't perfect. In fact, it's rather broken. At times, it seems more broken than ever. And I was thinking about this, and I was thinking back to when I graduated as an undergraduate with a bachelor's degree. That was a long time ago already, it seems like. It was 1973. What was happening then? There was a war. It was Vietnam. There was a government scandal. It was Watergate. There was an oil embargo and runaway inflation. And the Supreme Court reached an opinion on Roe versus Wade. And now here we are in 2022. We have all the same things just about. I'm going to call on you to change this cycle, so don't laugh too hard. We continue to fight and kill. The schism in our politics in the United States is deeper than it's ever been. Simple truths. We as scientists need to feel strongly about this, but simple truths are under assault. And the clock is ticking while we argue instead of act. So, we've done our best to cloister you from this imperfect world. We've kept you busy with test tubes, Erlenmeyer flasks, round-bottom flasks, high-powered lasers, etc. And you've done phenomenal things. But it's time for solutions to the problems that we face, and we rely, and indeed, we really depend on you for solutions. So, a few years ago, I was asked to give what for me was a very different kind of a talk. And I mulled over the idea, thought about not doing it, and in the end decided to do it, and came up with a title. And the title of the talk was, On Being a Scientist, or Thinking of Becoming One in a Time of Alternative Facts. It was a lot of work to pull it together, and I learned a great deal. And in fact, in the end, I think it was a lot of fun. At least for me it was. But I looked at a lot of public opinion polls on the public's perception of science, and it's very clear evidence that we scientists have work to do to help the public understand what we do, and maybe even more importantly, to trust us again, as they did in the past. Democratic institutions need science, and we need to help them, and that means you. Please consider this opportunity when it arises, because I know it will, and serve when asked. I have a short personal story about a public perception of science that I want to tell you about, and it's back quite a few years ago when our son Matt was only 4 years old. And I got invited to an anesthesiology meeting. Doug mentioned that we've done some work in the nitric oxide field, and the anesthesiologists worry about gases. And so they invited me to come and talk to them about the basic science discoveries involved with nitric oxide signaling. And if you asked Matt at the time what his father did for a living, he would say, my daddy is a science teacher. Anesthesiologists, as I mentioned, are interested in gas exchange, and when they invited me to the meeting, it was in February. I was in Michigan then. We lived in Michigan. February, Ann Arbor. The meeting was in a resort in Florida. You can figure it out. The whole family went. And while I was speaking, Margaret and Matt wandered past the room, and Matt wanted to peek in. So they came in, he had a look, and those were the days still of slide projectors and darkened rooms while you gave your talk. So when it was all over, I went back and I met up with them. Matt came running up to me. I said, well, what did you think? And he said, Daddy, why do you teach science in the dark? Now, that stopped me in my tracks. And I thought about it, and I guess the lesson here today, coming back to this public perception, we do a lot of what we do kind of in the dark. What we need to shine the light on it. The public truly needs to understand what we do and the value that comes from it. So, you know, in science, we like to make discoveries. Some are big, some are small, but they all have one thing in common. Everybody's starting with the same facts. One day, somebody wakes up, sees those facts in a unique way. Pieces of the puzzle fit together in a way that no one else saw. New ideas drawn from diverse backgrounds and life experiences are essential. So the diversity that I see out there, and the master's and PhD students behind me, is not the diversity I see behind me in the faculty. There's only one way to change that, and I urge you to stick with this and see it through, and someday, I would hope that you'll be sitting on a stage like this, changing the face of what American science looks like. So I'm an optimist. Those that know me know that that's my nature. And I'm very optimistic today for the same reason that Dean Clark said in his opening remarks. I'm optimistic because of all of you. I don't need to tell you that chemistry and chemical and biological engineering at Berkeley are great. You've heard that a few times already, but you know that having been a student here. But why is it great? Why is it that the college ranks with, and in fact is often judged better than the most elite private institutions in the United States? The faculty behind me might say it's due to them. But they know, and I know, that it's due to you. Now, the faculty are without question a guiding force. However, they have one common denominator that I came to appreciate especially when I was chair. The faculty don't think that there's any rules, that they can do whatever they want. And the reason and that's in fact sort of a chaotic sort of background to how Berkeley operates. But you students very quickly realize from the mentorship that you get, that there's no rules in this place. We can do whatever we want. And when you take brilliant, driven people like yourselves, and we put you into this cauldron, somewhat chaotically at times, of Berkeley chemistry, great things emerge. You know, I'm an experiment. I'm an experimentalist, and I know that this cauldron, it's a recipe for discovery. It's a recipe for solutions to big problems. And the result of the experiment is clear. So I'm optimistic about the future because I'm optimistic about what I know you will accomplish, especially given what you've learned and will take forward from here. There's another reason that I think Berkeley is unique, and that is that scientific boundaries don't exist. This is another great strength here. Berkeley is a home for science at the interface of disciplines, and for me, that's chemistry and biology at that interface. You might say, some of my colleagues here might refer to me as an organic chemist that's turned to the dark side. That's only partially true. I guess it depends, but I'll do my best to shine light on that dark side. But Berkeley is a great home for people like me that find research at the interface of disciplines, be it chemistry and biology, chemistry and physics, biological engineering and biology, chemistry and engineering married with materials chemistry. The opportunities at Berkeley are limited only by your imagination. So if you're to remember one message from today, I would like that to be that you keep an open mind as you approach the next phase of your life. Quite a few years ago, I read a book by Michael Shermer. Some of you might have heard of him. He's a pretty interesting character. He founded the Skeptic Society and Skeptic Magazine. But in the late 90s, he wrote a book entitled Why People Believe Weird Things. And in it, he takes on several topics such as alien abduction, creationism, ghosts, Holocaust denial, all topics that have elements within our society of people who believe that these things are real or certain things haven't happened. But he makes a very important point, and that's the lesson for today, though I encourage you to look at that book. It's pretty interesting. And that, he says, smart people are very good at rationalizing things they came to believe for non-smart reasons. We imagine ourselves as highly educated. In many cases, we at least have degrees to show that we have indeed that education. And Shermer's point is that we dig our heels in because of that. And we're actually not as open to new ideas as we should because we've fully rationalized the problem with the data at hand and we understand it better than anyone. So keep that open mind. In my office, I have a quote of Isaac Asimov, which he was a biochemist. Most people know of him for his science fiction writing. And his quote goes as follows: "The most exciting phrase to hear in science, the one that heralds new discoveries, is not eureka, but it's, that's funny." And that's the open mind, that you look at that and say, you know, that's not what I expected. And I can tell you, and you can look at this history of scientific discoveries yourself to see that that's funny is often the precursor to a phenomenal discovery. I have another quote in my office, hanging in my office. It was actually given to me, it's framed. It was given to me by Judith Klinman. She's a colleague in chemistry and one of my longtime friends. And the quote is as follows: "Never get angry, never make a threat, reason with people." Who said that? It was 50 years ago this year. Don Corleone, the Godfather, said that. But it's actually pretty good advice if you think about it. Keep an open mind and reason with people, and I can assure you that the path will be a lot easier. I have just one last word about adaptability. I don't know if any of you have you ever heard of the crocodile ice fish? So this is a fish that lives in the frigid waters of Antarctica. And it is the only vertebrate on our whole planet that doesn't have any hemoglobin. It's completely white. Now let's think about it. We got a bunch of chemists here, chemical engineers, biological engineers. Is oxygen more soluble in cold water or hot water? Let's hope it's cold water. So that water's pretty cold. That fish realized, I don't have to waste time making hemoglobin. There's enough dissolved oxygen in the water for me just to jettison hemoglobin and absorb oxygen from the water. That's pretty good adaptation. Okay, may have taken a few million years to do it, but it's pretty good adaptation. So I'm not telling you to jettison your hemoglobin. That'd be disastrous. But I'm just simply saying it to reinforce, adapt. You don't know what tomorrow's going to bring, but if you can adapt, you'll be successful. I might add in passing that as the waters of the ocean warm, that actually little fish is in a little bit of trouble. Okay, so it's called commencement. It's not called finishing. It's about starting the next phase and what that'll be. I can't tell you what that is. I was struck a bunch of years ago by a commencement address of all people that Meryl Streep gave. Did you contact her? She might have been. And this was at Barnard College in 2010, and she said, if you've been touched by the success fairy, people think you know why. So commencement speakers, there's like me standing here right now, are supposed to tell you, how we got to where we are, some inspiring story of how you're going to go forward. The honest story is I haven't the foggiest idea how things played out, but I think, coming back to the theme, I was adaptable. And that's my continued reinforcement of that message. But I do think successful people have a common denominator, and that is that they did something that they found interesting. They followed their nose to the end of wherever that interesting problem ended up, and that because of that, they never felt like they had a job. And I guess I would, in some sense, say that's both my advice and my success story. I didn't plan it out very well, but I adapted to what was in front of me. So in closing, I just want to leave you with a quote. It's a quote from John Kennedy. Like him or not, he gave some great speeches, and I would encourage you, any of the students here, to read some of those. In June of 1963, so this was just 5 months before he was assassinated, he was asked to give a commencement address at American University, and they gave him an honorary degree, and he used the speech. He had considerably more time than Dean Clark has given me today. He used the speech to convince us to reconsider our view of the Soviet Union. More importantly, to reconsider our view of the Russian people. He wanted us to change how we were thinking, because it looked like nuclear war was inevitable, and he wanted to stop that. And so in that speech, he said, "For in the final analysis, our basic common link is that we all inhabit this small planet. We all breathe the same air. We all cherish our children's future, and we are all mortal." I think those words beautifully frame the essence of our human existence, and I actually think about them every once in a while, and I placed them out there today hoping that you might consider those simple few words as you go about your daily lives. So, my time is up. I congratulate you. I wish you luck and good fortune. Our future depends on your success, and we'll be watching with both pride and anticipation. Thank you, Dean Clark, for the invitation, and thank all of you for listening.
Thank you, Michael. Adaptable as always, and I'm glad I made you an offer you couldn't refuse. It is now time to recognize some of our most outstanding graduates of 2022. But let me say first that in general, this year's graduating class of the College of Chemistry continues to demonstrate Berkeley's excellence by virtue of the breadth and number of awards received, honors bestowed, job opportunities offered, and admission to the top graduate programs in the world. In short, our students continue to excel, inspire, and amaze. So I would now like to ask each of the following graduates to come forward and stand at the edge of the stage until I call your name again. Nadia Berndt, Nhi Tran, Golsa Gaby, Jiaoqi Swen, Ryan Golden, Roland Ace Aguilar, Chuing Huang, Tyler Wang, Emily Zhang, and Riley Togashi. So each of the departments annually selects a winner of the departmental citation, which recognizes overall excellence in scholastic performance in the major. This is the highest and most prestigious of the commencement awards, and this year's winners are Nadia Berndt in chemistry and Nhi Tran, chemical and biomolecular engineering. Please come forward. In 1998, the college inaugurated an award for excellence in undergraduate research, one in each department. The Glenn T. Seaborg Award for outstanding undergraduate research in chemistry is given to Gulsa Gaby. The John M. Prausnitz Award for outstanding undergraduate research in chemical engineering goes to Jiaoqi Swen. The Eric O. and Ellie M. Segabarth Prize in Chemistry is endowed by the family and friends of Dr. and Mrs. Segabarth in their memory. The prize is given to recognize outstanding graduating seniors who plan to pursue graduate studies in chemistry and, quote, who have the skill and drive to advance chemical science and the profession, end quote, which is what Eric Segabarth devoted his life to. This year, the recipient of the Segabarth Prize is Ryan Golden. The George C. Pimentel Award was established to encourage promising students to engage in undergraduate research and pursue their science education. Every year, this award is given to a graduating senior who has carried out undergraduate research, is planning to go on to graduate education in chemistry or a related field, and is a member of the first generation in his or her family to be privileged to attend college. This year's recipient of the Pimentel Award is Roland Aguilar. The Kulu Seo Khan Award is endowed by Mr. Joseph Koo and Dr. Helen Koo in memory of Mr. Koo's late mother. The award is presented annually to one or more outstanding seniors in the Department of Chemistry on the basis of outstanding academic achievement. This year's recipients are Chuing Wang, Tyler Wang, and Emily Zhang. The Jack and Bearda Kirsch Prize is endowed by the late Professor Jack Kirsch and his wife, Bearda Kirsch. The new award will be presented annually to one of the top undergraduates in the chemical biology program. This year, the award goes to Riley Togashi. The Excellence in Peer Student Services Award is presented to students that have demonstrated excellent service in the peer tutoring program, peer advising program, or as a chemistry scholar's education lead. Peer tutors, peer advisors, and the College of Chemistry Scholar Educational Leads provide their undergraduate peers with advising, tutoring, and academic teaching support. Would the following students please stand and remain standing in place? Joshua Leong, Artur Lysenko, and Caitlin Reed. Please give them all a round of applause. Congratulations to you all. Please be seated. At this point, I would also like to acknowledge our most accomplished seniors for their excellence in undergraduate research. Would the following students please stand and remain standing in place. Amala Akiraju. Elena Belk. Erica De Leon Sanchez. Jeffrey Ha. Kendra Tutt. Calvin Hu. Anukta Jain. Ghazal Kamyabi. Lydia Chavez, Victoria Bernardi. Each of these students received a Senior Undergraduate Research Award for their outstanding research accomplishments spanning over several semesters at Berkeley. Please give them a hearty round of applause. Congratulations to you all. You may now be seated. Would Diptarka Haidt please stand and remain standing in place? Briefly. Diptarka received the Pimentel Research Award for Graduate Research. Please give her a round of applause. Congratulations, Diptarka. Please be seated. Would Audrey Reeves please stand and remain standing in place? Audrey received the Benjamin Bousser Memorial Award, which is presented each year to a graduating doctoral student who exemplifies Ben's commitment to creating positive social or environmental change, either through dissertation research or through other channels such as science policy or educational outreach projects. This year, the focus was on diversity, equity, and inclusion in academia and STEM education. Please give Audrey a round of applause. And congratulations to all of our student awardees. And now, we recognize a few of our distinguished faculty members. The Departmental Teaching Award is presented to a faculty member in each department in recognition of their exceptional teaching. This award is based upon nominations submitted by our graduating students. The recipient of this year's awards are Anne Berenger in chemistry and Karthik Sharkar, chemical and biomolecular engineering. Unfortunately, Karthik did not attend today's ceremony, but Anne is here. Which brings us to our last award, the Noyce Prize. Donald Sterling Noyce Prize for Excellence in Undergraduate Teaching is given annually to a faculty member in the physical sciences, not just chemistry, who has demonstrated unusual success in undergraduate education, including work in the area of curriculum development. This year's Noyce Prize recipient is chemistry professor David Limmer. Well, now we get to the main event you've all been waiting for, which is the presentation of degrees. Would anyone out there like a degree? Well, you've come to the right place. So when Professor Anne Berenger or Professor Kranthi Mandatapu calls your degree group, please stand and form a line at the edge of the stage. I will now call upon Anne Berenger, Professor of Chemistry, to announce the BS degree recipients in chemistry. Will the degree candidates please rise and line up at the edge of the stage?
Christopher Chan. Hannah Nicole Castro. Catherine Lynn Hoffman. Julia Greenbaum. Erica Elise DeLeon Sanchez. Erica Zhang. Casey Feng Yin. Ian Gutierrez. Fabian Edward Valencia. Luis Garcia. Joshua G. Nang Liang. Tyler Christopher Wang. Vida Sanchez. Artur Lysenko. Flora Fan. Kainalu Miata Smith. Ryan Golden. Reese Dorrit. Timothy Chang. Woo Sung Kim. Nadia Berndt. Audrey Nim Bartlett. Shiloh Jaxie Syed Anderson. Odelia Simon. Ghazal Kamyabi. Minji Lee. Sam Hong Kyo Tang. Kevin Ru Zhao. Dylan Clark Umfress. Alberto Mirror. Nilabjo Maitra. Feng Zhao. Roy Wang. Chloe Alice Babyak. Lun Ling Tian. Aram Alexander Butler Sloss. Nagar Baradaran. Mai Huyen Trang Chan. Chuan Huang. Golsa Gaby. Amulia Grandi. Elena Belk. Linda Solis Chavez. Rachel Redman.
Okay, and now comes the really fun part. By virtue of the authority vested in me by the President and the Chancellor, I grant you the degree of Bachelor of Science in Chemistry. Professor Behringer will now read the names of the BA degree recipients in chemistry. Will the degree candidates please rise and line up at the edge of the stage?
Paola Cecilia Martinez Contreras. Corinne Kalani Hickman. Arya Lal. Grace Santos. Lena Marjanovic. David Chen. Jeremiah Yoon.
By virtue of the authority vested in me by the President and the Chancellor, I grant you the degree of Bachelor of Arts in Chemistry. Professor Behringer will now announce the names of the BS degree recipients in chemical biology. I think you all know what to do.
Okay. Tava Carlin Raye Pritchard. Julia Claire Bagger. Sarah Sagu. Kenny Solis. Catherine Genevieve Delaveau. Charmaine Fong. Youssef Hashmi. Patrick Christopher Huang. Jae Hyun Lu. Jun Pyung. Sue Kim. Henry Janode. Calvin Jiao Yang Hu. Matthew Nobuhiro Kojima. Brian Richard So. Emily Zhang. Mirai Julia Key. David Han. Jean Lee. Amanda Jackie Lee. Chi-Wen Lee. Alan William Liang. Letitia Matsubara de Moray. Victoria Violet McElrath. Evelyn Lee. Roland Ace Aguilar. Emma Madeline McRae. Theodore Clark Blunden Morgan. Scott Nee. Cassandra Rapp. Caitlin Randall. Manasa Narayanamurthy. Riley Kaiichi Nogashi. Matthew Rickey. Claudia Ann Smith. Julia Driscoll. Isabella Irene Turqueza Nanka. Chao Don. Yiming Kwang. Yongyi Mo. John Thorup. Caitlin Isabel Ree. Ryan Rue. Erin Lynn Rickman. Elena Kim Ng. Yu Shi. Devin Trinter. Shreya Shriram. Drew Xiang. Madeline Elizabeth Sanders. Kali Christina Zervis.
By virtue of the authority vested in me by the President and the Chancellor, I grant you the degree of Bachelor of Science in Chemical Biology. I now call upon Kranthi Mandadapu, Professor of Chemical and Biomolecular Engineering, to announce the BS degree recipients in Chemical Engineering.
Radesh Amin. Eugene Hong. Ni Tran. Quinn Truong. Zoe Su. Emily Blair Heyman. Ryan Fuad.
Hi, Mom.
Zoe Altenberg. Hunter Mastretti. Bruna Augusto Silvestri. Youngjin Song. Shaoqi Swen. Kendra Christina Tutt. Brittany Tran. Ivan Sandoval. Angelica Love Castro Laraquel. Meera Patel. Amala Akiraju. Steven Roberto Chang. Victoria Venardi. Nishi Taplial. Siddhartha Barua. Anthony Stephen Mayer. Sofia Merenin Sidir. Bora Osjon. Elijah Keith Sherritt. Amy Lay. Pranav Tandon. Talia Alnatur. Anukta Jain. Marisa Brizeño. Armina Mary Guevara. Garrett Vincent Pullman. Aidan George Newbolts. Jonathan Klein. Chandini Dialani. Sharan Raghavan. Nicholas Edward Solin. Joshua Bay. Daoming David Wang. Daniel Alexander Reidenbach. James Marquez. Kobe James Houston Garcia. Riley Bingham Mankin. Jesse Thomas Mikulek. Elise Alexandra Dawson. Austin Joseph Stark. Robert Alexander Kapp. Ihab Almasri. Vanessa Zambrano. Sahel Patel. Ariana Dunlap. Alfonso Aguirre. Noah Isaac Bussell. Charles Wynn. Christian Alexander Fernandez. Eduardo Negrete Molina. Carlson Pradama Sugiardo. Yusuf Bader Al-Hamadi. Faisal Al-Dosari. Aiden Esparza. Ali Al-Muhanna. Tristan Hanil Yu. Alexander Kane. Kori Hiroshi Kato. Tue Albert Wang Tai. Edward Shu. Mingchi Wang. Emily Ruan. Stephen Gu. Kishan Arya Somayajula. Kushan Bal. Wesley Wang, Clay Sai, Jacob Anthony Castorena, Spencer Valenti, Jose Andres Vidal, Nicholas Larson, Jacob LaRue, Nathan Lee, Sachin Murthy, Cody Chang, Philip Yuchen Tu, Rosa Zhang, Jeffrey Ha, Ciprian Matei, Alexia Lee, Niharika Gupta, Nicole Ann Nelson, Ava Sabine, Elizabeth Ann Greenberg, Laura Hernandez, Jason Ho, Bernard Tanderitz, Priscilla Evangelista,
By virtue of the authority vested in me by the President and the Chancellor, I grant you the degree of Bachelor of Science in Chemical Engineering. Now for the Professional Degree Masters in the Product Development Program. Executive Director Keith Alexander will read the names of the MS degree recipients in Chemical Engineering Product Degree Development Program.
No, not till you come back. Okay. Oh, you're not going to take a picture. Okay, great. Great. Fantastic. All right, thank you. Fantastic. Yurong Zhu. Shi Wang. Too fast. Ike Lu. King John Nathan Fong. Those ones here. Okay. Ishan Ruan. Okay, shall shoot. Thank you. Jilong Zhong. Oh, here's it. Sri Shruvi Pamuda. Yeah. Pallavi Gato. Isha. Right. Isha Liang. Gwingman Mu. Nenjing Chen. Okay. Yuele Zhong. Luwen Chen. Jilun Zhong. Christopher Skangles. Here's it. Gamu Chiri Elizabeth Chifamba. Christina Jenny Luong. Ojazwi Rathi. Clara Tawadras. Medhave Sagal. Komal Gupta.
Yes, come on!
Sichin Liang. Maria Catalina Vallota Reyes. Claire Marie Eustace. Brian Fennell. Jason Paul De Silva. Spencer Hutchins. Eid Fahad Hilal. Okay.
By virtue of the authority vested in me by the President and the Chancellor, I grant you the degree of Master of Science in Product Development. This is fun, isn't it? Now, for the Professional Degree Masters in the Bioprocess Engineering program, Executive Director Jason Ryder will read the names of the MS degree recipients in Chemical Engineering, Bioprocess Engineering program. And Chair Jeff Reimer will join me in congratulating the recipients.
Elena Anand. Brooke Wilson. Bonnie Fong. Alan Wong. Shreyas Saban. Mick Eric Oatsma. Victoria Oliveras. Kirch Zarina Batoy Quijano. Sarah Aleja Acosta. Zaid Qasim.
and by virtue of the authority vested in me by the President and the Chancellor, I grant you the degree of Master of Science in Bioprocess Engineering. I now call upon Chair Francis, who will read the names and thesis titles of the PhD degree recipients in chemistry. Each student will be hooded by their faculty research advisor or, in their absence, Dean Arnold or a colleague.
Jason J. Calvin, advised by Paul Avasados, hooded by Matthew Francis. Organic ligands and colloidal nanocrystal thermodynamics. Jakob Shays Dahl, advised by Paul Avasados, hooded by John Arnold. Formation and transformation of metal halide nanocrystals. Jade Phosphate, advised by John Arnold. Design of niobium and tantalum systems for small molecule activation. Francis Yu Ting Lam, advised by Polly Arnold, hooded by John Arnold. F-block complexes of chelating tetraphenylates and their applications in catalytic dinitrogen functionalization. Catherine Ann Blackford, advised by Ann Berenger. Progress toward the synthesis of as-novelin E, design and evaluation of online chemistry experiments, and an investigation of metacognition in organic chemistry students. Audrey Glenn Reeves, advised by Chris Chang, hooded by John Arnold. An activity-based oxyzirridine platform for identifying and developing covalent ligands for functional allosteric methionine sites. Jason Fang, advised by Michelle Chang. Aldolase catalyzed synthesis of chiral organofluorines. Joy Yiran Wang, advised by Jennifer Doudna, hooded by John Arnold. Structures and mechanisms of CRISPR-Cas adaptive immunity. Raymond Edward Blackwell, advised by Felix Fisher. Exploration of magnetic edge and dopant states in nanographenes. Ryan McCurdy, advised by Felix Fisher, a chemist's approach to graphene nanoribbon electronics. Colin Joseph Steen, advised by Graham Fleming, snapshot spectroscopic studies of the in vivo regulation of photosynthetic light harvesting and photoprotection. Jonathan Charles Maza, advised by Matthew Francis. Development of an enzymatic oxidative coupling bioconjugation and its application in the synthesis of immunoconjugates. Paul Ryan Rona, advised by Philip Geisler and Iran Rabbani, on the phases and thermodynamics of indirect excitons. Trevor Dale Roberts, advised by Naomi Ginsberg. Elucidating nanoscale dynamics of matter and energy transport in heterogeneous systems using time-resolved spectroscopies and microscopies. David Matthew Lunderberg, advised by Alan Goldstein, hooded by John Arnold. Sources, physiochemical transformations and inhalation exposures of indoor organic chemicals. Kira B. Wilhelm, advised by Jay Groves, hooded by John Arnold. Developing a novel class of synthetic T-cell receptor agonists to quantitatively interrogate T-cell signaling. Stephen George Hanna, advised by John Hartwig. Tandem catalytic processes involving olefins. Eric Daniel Kalkman, advised by John Hartwig. Investigations into the reactivities of transition metal fluoroalkyl complexes for the formation of fluoroalkyl arenes. Miranda Josephine Barron, advised by Brett Helms. Selective transport and microporous polymer membranes for emerging battery technologies. Deptarka Height, advised by Martin Head Gordon. A density functional odyssey beyond ground state energies. Elliot Connor Rossamy, advised by Martin Head Gordon. First principles computational approaches to advancing green chemistry. Josie Hendricks, advised by Martin Head Gordon. From soot to space, application of density functional theory and development of tight binding methods. Christopher Tanu Jackson, advised by Marquita Landry, hooded by John Arnold. Chemical engineering of nanomaterials for the delivery of biomolecular cargo. Bethany DeRoulet, advised by Steve Leone, hooded by John Arnold. Charge carrier dynamics in metals and metal semiconductor junctions, studied by transient absorption and photoemission spectroscopy. Andrew Dean Ross, advised by Stephen Leone and Dan Newmark, hooded by Dan Newmark. Ultrafast dynamics, studied by few femtosecond soft X-ray transient absorption spectroscopy. Avishek Thus, advised by David Limmer, variational sampling and optimal design of rare non-equilibrium molecular dynamics. Kai-Peng Ho, advised by Jeffrey Long, hooded by John Arnold. Bio-inspired dioxygen activation in metal organic frameworks, oxidation of hydrocarbons, and characterization of metal oxo species. Joshua Luke Turnbull, advised by Evan Miller, hooded by John Arnold. Developing phosphonated xanthine fluorophores for live cell imaging applications. Lydia Eulalie Boyk, advised by Daniel Nomura. Chemoproteomics enabled discovery of covalent inhibitors and novel induced proximity platforms. Nathaniel James Henning, advised by Daniel Nomura. Harnessing covalent chemical probes for inhibition to induced proximity modalities. Dipti Jasprasaria, advised by Iran Rabbani, an atomistic understanding of non-radiative processes in quantum dots. Charles Winslow, advised by Jonathan Riddle, hooded by John Arnold. Small molecule activation at transition metal complexes of a sterically encumbered multidentate phosphinamide ligand. Ian Buchanan, advised by Richmond Sarpong. Synthetic studies toward zeamycin type indolosesquiterpenoids and melicolone natural products. Jinsu Ham, advised by Richmond Sarpong. Development and application of transition metal catalyzed CC bond functionalization. Justin Edward Jursic, advised by Richmond Sarpong. Strategies toward saturated cyclic amine diversification. Robert Lucy, advised by Richmond Sarpong. Strategies in complex molecule synthesis enabled by scaffold remodeling and late-stage CH functionalization. Sebastian Santiago Gonzalez, advised by Alana Shepards, hooded by John Arnold. Genetic code expansion in Vibrio nitrogens. Stephen Marion Biershank, advised by Dean Tost and Ken Raymond. Development of highly selective transformations catalyzed by a new class of enantiopure supramolecular hosts. Banro Huang, advised by Dean Tost. Mechanism-guided discovery of catalytic processes and organic materials. Nikita Hennikel, advised by Omar Yagi, hooded by John Arnold. Atmospheric water harvesting with metal organic frameworks. Fungjing Jin, advised by Omar Yagi, hooded by John Arnold. Crystalline entangled covalent organic frameworks. Haozi Wang, advised by Omar Yagi, hooded by John Arnold. Design, functionalization, and evolution of metal organic frameworks. Chubai Chen, advised by Peidong Yang. Tandem strategy and conversion mechanisms in electrochemical CO2 reduction reactions.
By virtue of the authority vested in me by the President and the Chancellor, I grant you the degree of Doctor of Philosophy in Chemistry. Chair Reimer will now read the names and thesis titles of the PhD degree recipients in chemical engineering.
Kevin Gao, advised by Natasha Balsara, Transport and Thermodynamics in Polymer Blends and Electrolytes. Hooded by Natasha Balsara. Lorena Shannon Grundy, advised by Natasha Balsara and hooded by Natasha Balsara, morphological and electrochemical responses of block copolymer electrolytes to magnetic, electrochemical, and mechanical forces. Julie Christine Fornusari, advised by Alexis Bell and Adam Weber, and hooded by Adam Weber. Optimizing transport phenomena in electrolytic cells. Some technical difficulties. Dana Nozick, advised by Alexis Bell, hooded by Alexis Bell, mechanism and kinetics of propane dehydrogenation and ethene oligomerization and hydroformylation over Bronsted acidic and metal exchange zeolite catalysts. Oyen Kensola Romiluyi, advised by Alexis Bell and Adam Weber, hooded by the two of them, design and investigation of membrane electrode assemblies for the electrochemical reduction of CO2. Anthony Abel, advised by Dean Douglas Clark, an analysis of electromicrobial production technologies for Earth and space applications, hooded by Doug Clark. Kevin Ikeda, advised by Martin Head-Gordon, hooded by the same, and his thesis, a second-generation, second-order Mollier-Plesset perturbation theory energy decomposition analysis for intermolecular interactions utilizing global virtual space. Francis Cunningham, advised by Marquita Landry, hooded by John Arnold, nanoparticle-mediated delivery of CRISPR-Cas9 proteins to plants. Natalie Go, advised by Marquita Landry, hooded by John Arnold, leveraging nanomaterial interactions with plant cells to enable nanomaterial-mediated genetic engineering. Caitlin Engler, advised by Jeffrey Long and Jeff Reimer, magnetic resonance characterization of porous material for batteries and quantum sensing applications, Dean Arnold Wilhood. Saria Parker, advised by Jeffrey Long, John Arnold Wilhood, application-focused design and development of amine-appended metal organic frameworks for CO2 capture. Adam Uliana, advised by Jeffrey Long, hooded by John Arnold,
multifunctional membranes and porous polymer adsorbents for selective ion and gas separations. Ever Velasquez, advised by Jeffrey Long and hooded by Kranti Mandarapu, optimizing performance of metal organic frameworks for gas separations and storage. Amaresh Sawu, advised by Kranti Mandarapu, irreversible thermodynamics and hydrodynamics of biological membranes, hooded by Kranti Mandarapu. Clay Henry Batten, advised by Kranti Mandarapu, statistical mechanics of lipid membranes, hooded by Kranti Mandarapu. Kara Danielle Fong, advised by Brian McCloskey and Kristen Person, ion correlations and transport in lithium-ion battery electrolytes, Brian McCloskey hooding. David Emery Brown, advised by Brian McCloskey, lithium-ion battery limitations under extreme operating conditions, hooded by Brian McCloskey. Elise Kedsey, advised by Brian McCloskey, investigating reaction mechanisms in metal-air batteries, hooded by Brian McCloskey. Angelo Domenico Bonzanini, advised by Ali Mesbah, hooded by Ali Mesbah, learning-based model predictive control for nonlinear systems with applications to cold atmospheric plasmas. Christopher Ryan Barnes, advised by David Schaefer, hooded by David Schaefer, cellular and protein engineering for increased efficacy for gene therapy. Sarah Giachi Young, advised by Marquita Landry and David Schaefer, hooded by David Schaefer, synaptic scale imaging of dopamine distribution in Huntington's disease model mice with near-infrared catecholamine nanosensors. Nicholas Zill, PhD with Wenjun Zhang, the discovery of novel bioactive small molecule natural products through metabolomic method development and genome mining, hooded by Professor Wenjun Zhang.
By virtue of the authority vested in me by the President and the Chancellor, I grant you the degree of Doctor of Philosophy in Chemical Engineering. I would now like to close this ceremony with just a few brief remarks about this wonderful occasion. First and most important, I extend my warmest congratulations to our graduates and welcome you to permanent membership in the College of Chemistry community as alumni. My colleagues and I wish you the very best in your careers and lives and hope that you will all stay in touch with us and keep us informed of your future accomplishments. Second, I would like to extend my sincere thanks to the families and friends of our graduates who are all in the audience this afternoon. The successes of the graduates sitting before us would not have been possible without your sustained love and support. All of you have played a vitally important role in bringing us here today. My colleagues and I applaud your efforts and share your pride and accomplishments in these very impressive young men and women. And finally, graduating from the College of Chemistry carries with it a responsibility that continues after you leave Berkeley. Now more than ever, we depend on our alumni to continue to support the teaching and the research carried out here, and we hope that you will remember us as you move into your future careers. But don't worry too much. We'll remind you of that. And as just one example of giving back, our undergraduate and graduate students both had crowdfunding campaigns this year, which raised funds to further enhance our college's diversity and inclusion initiatives and develop more student alumni mentorship and advising opportunities. I would like to thank the student leaders who played a major role in these crowdfunding campaigns, and I'd also like to thank all of you who contributed to this year's campaign, and I hope you will consider remaining engaged and giving back to our college in future years. And this brings us to the end of our ceremony. The procession of faculty will leave in the same order in which we entered the auditorium. After our graduates have marched out, you are all invited to join us for refreshments and a reception on the plaza. So I will leave you with this. Former College of Chemistry Dean Glenn Seaborg, who also happened to be our second chancellor, a Nobel laureate, and advisor to 10 US presidents, once noted that many people believe that, quote, science should move us toward a utopian, problemless, riskless society. This is a false notion. We live and always will live in a dynamic situation amid problems whose solutions will breed other problems. There always will be dangers, risks, and increasing responsibilities that will drive us towards a new level of excellence in all we do or try to achieve, end quote. Well, it is now your time, College of Chemistry graduates, to drive toward a new level of excellence in all you strive to achieve. Congratulations, best of luck to you all, and as always, go Bears.